All right, we all know large language models are pretty amazing, but they have this one huge, glaring flaw. They hallucinate. Now, the big solution was supposed to be Retrieval-Augmented Generation, or RAG, which grounds the AI in real documents. But it turns out RAG has its own hidden flaw, and that's what we're diving into today. A really powerful new paradigm called RAS, which stands for Retrieval and Structuring, that's designed to fix it for good. And really, it all boils down to this one question. Why can an AI with access to literally all the information in the world still get tripped up? Well, the answer is surprisingly simple. It's not just about having the information, it's about the quality of that information. You know, when you feed an AI a messy, disorganized pile of text, well, even the smartest model is going to get misled. So here's what we've got on tap. We're going to start by digging into RAG's hidden flaw. Then we'll pull back the curtain on the RAS paradigm and explain how it works. We'll get into the nitty-gritty of structuring data, see how it performs in practice, and then we'll look ahead to what this means for the future of AI reasoning. All right, let's jump right in. Because, to really get why the solution is so cool, you first have to understand the problem. And that problem starts with the current industry go-to, RAG. Look, RAG was a great first step, no doubt about it. It hooks an LLM up to external data to stop it from making things up. The thing is, it just grabs raw, totally unstructured text. RAS, on the other hand, adds that game-changing S for structuring. It's not just about retrieving, it's about retrieving and then structuring. It's this crucial extra step of organizing the info before the AI even lays eyes on it. Yeah, you can really think of this as a bottleneck. It's like trying to pour water through a funnel that's clogged with a bunch of junk. Because RAG is processing this raw, messy text, it's pulling in all this irrelevant, confusing fluff that can totally poison the model's reasoning. And that's why RAG just falls apart when you ask it complex questions that require putting a few different ideas together. So that brings us right to the solution, the RAS paradigm. It's a really elegant fix for RAG's whole messy data problem. And honestly, it all boils down to one simple, game-changing addition. So what exactly is RAS? Well, at its core, it just extends RAG by adding that knowledge structuring step. It doesn't just grab text, it actively turns that text into organized knowledge. You can almost picture a knowledge graph like a super detailed mind map for the AI. It's not just a list of facts, it connects all the dots. Who's related to what causes what, the whole shebang. This combines finding information, organizing it, and then generating an answer into one much smarter process. And the best part? The basic process is super simple to understand. First, just like RAG, it retrieves the relevant documents. But here it is, step 2. This is the magic part that RAG just completely skips over. It structures that raw info, turning that mess into a clean, logical knowledge graph. And only then, in step 3, does the LLM use that beautifully organized knowledge to build a way more accurate and trustworthy answer. I love this analogy because it just hits the nail on the head. A regular LLM is like a brilliant student trying to answer everything from memory. Impressive, sure, but they're going to make mistakes. RAG is like giving that student a huge, messy pile of research papers. Better, but they still have to wade through the junk. But RAS, that's the truly smart student who takes the time to organize all those papers into a perfect outline before they even start writing. So yeah, RAG gives the AI access to the library, but RAS gives it a personal, super organized research assistant. The final result is just on another level. Okay, so we've got the what and the why, but what about the how? How does RAS actually pull off this critical structuring step? Let's get into the mechanics of turning that messy text into clean knowledge. It really breaks down into a clear 4-step workflow. First up, you create a taxonomy, basically a family tree of concepts, going from big, broad ideas down to the nitty-gritty details. Second, you enrich that tree, adding descriptions and keywords to make everything clearer. Third, you extract the key info, the people, places, things, and how they're all connected. And finally, you take all of that and build it into that clean, coherent knowledge graph we've been talking about. And hey, this isn't just some abstract theory. Now, we don't have to get bogged down in all the names here, but take a tool like Rebel, for instance. It's designed to read a sentence and automatically pull out the relationships, forming the building blocks for one of these knowledge graphs. The main takeaway here is that RAS is built on a whole field of established research. These are real tools that are already out there powering this whole structuring process. Okay, so the theory sounds solid, right? The tools are there, but the big question is, does it actually work in practice? let's take a look at the real-world impact and the kind of performance boost you get when you put RAS to the test. And wow, this chart right here says it all. It shows the performance lift you get from using RAS over standard RAG. And it doesn't matter if you're using a big, closed-source model or one of the open-source ones. The result is crystal clear. RAS gives you a huge, measurable performance boost. Plain and simple, it just gets you better, more reliable answers. And get this, that simple process we talked about, that's just the beginning. The really powerful version of RAS is dynamic and iterative. It's like having a personal research assistant who doesn't just use a pre-made outline, but creates a brand new, custom-tailored one for every single question you ask. This whole advanced cycle works a lot like a detective on a case. First, it plans its attack, breaking a big question down into smaller ones. Then, it narrows the search, focusing only on the most relevant stuff. Step 3 is where the real magic happens. It dynamically pulls apart sentences and turns them into structured data, subject, verb, object, and builds a custom knowledge graph on the fly, just for your query. And finally, it uses that custom-built graph to put together an incredibly precise answer. Okay, so RAS is obviously powerful, but let's be real, it's not a magic bullet. There are definitely some big technical hurdles we need to talk about. For one, efficiency. All those extra structuring steps can add time and slow things down. Then there's knowledge quality. I mean, if the automated tools mess up while they're structuring the data, you're not creating knowledge, you're just organizing garbage. And finally, just getting the structured data to play nice with the LLM is a pretty serious engineering puzzle. But hey, even with those challenges, RAS is clearly pointing the way to a whole new horizon for AI. So to wrap this up, let's take a quick look at where all of this might be heading. And the road ahead here is, well, it's pretty exciting. People are already working on multimodal systems. I mean, just imagine an AI that can watch a dense physics lecture on YouTube and instantly build a perfect knowledge graph out of it. Or cross-lingual systems that can structure knowledge across different languages, not just translate words. And ultimately, systems that learn from conversation and combine the raw power and scale of the machine with the subtle, nuanced judgment of human experts. That's the dream, right? One of the researchers behind this paper summed it up perfectly with this quote: RIS is the next step in moving LLMs from impressive but imperfect tools into reliable, knowledge-driven systems. That's really what it's all about, moving from something that's just impressive to something you can actually rely on. And all this leaves us with one final, pretty deep question to chew on. We've seen how organizing information makes AI way better. But could it be more than that? Is this it? Is the simple act of structuring knowledge, of organizing information, the actual key to unlocking something that looks like true artificial reasoning? Maybe it's not about bigger models, but smarter data. Something to think about. Thanks so much for tuning in.